All right, I wanted to revisit even and odd functions and see if we might be able to demonstrate this a little more clearly so that we can really see what we're talking about with these even and odd functions. So there are kind of three ways we can identify if a function is even or odd or neither. The first would be graphically. We could also do it using a table of values, a table of values or coordinates. And then finally, algebraically, which is kind of what we're learning, but is kind of the trickiest to understand. So I want to save that for last. So if we look at graphically, right, we know that an even function is going to be symmetric across our y-axis. So we can see, for example, this graph of f of x equals x squared. We can see the symmetry here. Our axis of symmetry is x equals 0. And so we can see that that is an even function. Now, what this looks like in a table is simply this. If we have x squared, right, we know that 0 squared would be 0. So when x is 0, f of x is 0. When x is 1, 1 squared would be 1. And when x is 2, 2 squared would be 4. Now, if we look at our negative values, when x is negative 1 squared is positive 1. And when x is negative 2 squared is positive 4. And so we can see in this table of values that same symmetry again that we see in the graph, right? Our x is 1 and x is negative 1 have the same y value or f of x value. And the same is true for 2 and negative 2. So we can see that, oh, when I have positive 1, my answer is 1, or my f of x value is 1. And when I have negative 1, my f of x value is 1. So they're the same. And so that takes us to looking at it algebraically, which at first can look a little bit confusing, but it's just this. It's the exact same thing as our table. So algebraically, we say that f of negative x is equal to f of x. And so that looks a little bit weird, but all we're saying is that if I take the negative version of an x value, I'm going to get the same output, the same value, as the positive version of that same x value. So what I mean by that is when we look at our table again, if I take f of 2, I get 4. Now if I take f of negative 2, right, a negative version of my x value, I also get 4. So f of 2 would equal positive 4, and f of negative 2 also equals positive 4. So to show this algebraically, we just find f of negative x. So you say, all right, I know that f of x is equal to x squared. So f of negative x is going to be negative x squared. And we can simplify this. We know that negative x squared, or negative x times negative x, would simply be x squared. So f of negative x equals x squared. And we can see that that means when I take my negative value of x, I still get the exact same thing as when I have the positive value. F of x equals x squared, and f of negative x equals x squared. And again, we see that in our table, right? When I have x equals 2, f of x is 4. When I have x equals negative 2, f of x also equals 4. If I continued this outward, f of 3 would be 9, f of negative 3 is 9. Let's look at another example of that. So here we have f of x equals the absolute value of x. So again, if we were to look at our graph, again, we can see that axis of symmetry at x equals 0. So graphically, we know that this is an even function. If we look at the table, right, f of x equals the absolute value of x. Well, the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And the absolute value of 2 is 2. So again, we can see the symmetry in our table, and we can see that when I have positive 1 as an x value, I get positive 1 for f of x. And when I have negative 1 as an x value, I also get positive 1 for f of x. And again, algebraically to show that, f of negative x, if it's an even function, will equal f of x. So we know that f of x is equal to the absolute value of x. And so we're going to see if f of negative x is the same. And so that means we would be finding the absolute value of negative x. And we know that a negative with absolute value would just become positive. So that means f of negative x is equal to the absolute value of x. And so we get the same thing. In other words, f of negative x equals f of x. So this is an even function. Now let's look at a different function. So here we have a linear function. F of x equals 4x. So graphically, we can see that this is not an even function. It's not symmetrical across x equals 0, across the y-axis. We may, though, be able to see that this is actually an odd function, because if we were to rotate this 180 degrees, we would get the same function. And so we can see that that is, by definition, an odd function, looking at the graph. Now, let's look at it again in a table of values. So let's start at 0. F of 0 would be 4 times 0, which is 0. F of 1 would be 4 times 1, which is 4. And f of 2 is 4 times 2, which is 8. Now, going into the negatives, f of negative 1, that's 4 times negative 1, which is negative 4. And 4 times negative 2 is negative 8. And so, algebraically, what we say with an odd function is that f of negative x equals negative f of x. And again, it can get confusing looking at this function notation, but all that's saying is when I take the negative version of an x value, I get the negative version of its output, of its f of x value. So if we look here, right, when x is 1, f of x is 4. When x is negative 1, so I'm taking the negative value of 1, then f of x is negative 4. In other words, I took this 4 and it became negative. So f of negative x is the negative f of x. Again, hearing it in that function notation may be confusing, but seeing it in this table of values should help you see that. So we can see again, right, if we were to have x is 3, we know that 3 times 4 is 12. So we know that negative 3 as our x value, we would get the opposite of 12, and we would have negative 12. So this is an odd function. And again, we can show this algebraically, because we know that f of negative x should equal negative f of x. That's the definition of an odd function. So if we take f of x, which is 4x, and we substitute negative x, we get f of negative x is 4 times negative x, and 4 times negative x is negative 4x. And again, we can see that f of x equals 4x, and f of negative x equals negative 4x. And again, that is negative f of x. It's the opposite of our original function. Okay, here's another one. Again, we can see graphically that this is an odd function. We could rotate it 180 degrees about the origin and have the same image. And let's look at this in a table of values. So we have x cubed. So again, we'll start at 0. 0 cubed would be 0. 1 cubed would be 1. And 2 cubed would be 8. Then looking at negative 1, negative 1 cubed would be negative 1 times negative 1 times negative 1, which is negative 1. And then negative 2 cubed, negative 2 times negative 2 times negative 2 would be negative 8. So once again, we can see f of x, right? F of 1 would be positive 1. F of negative x, f of negative 1 is negative 1. So again, we get the opposite value, and we can see rather than the perfectly symmetrical even functions, right? We get something where we get an opposite, right? So if this point here represented positive 20, then we would know this point down here, the opposite would be negative 20. So let's look at that algebraically. So again, f of x is equal to x cubed. And so f of negative x will equal negative x cubed. And we know that negative x cubed will equal negative x cubed. And so again, we can see that f of negative x is going to be the opposite of f of x. In other words, f of negative x equals negative f of x. Now finally, let's look at an example of a function that is neither even nor odd. So we can see that there's no symmetry across the y-axis, and there's also no symmetry about the origin, because we can see that this graph does not run through the point 0, 0, so we can't have symmetry about the origin. If we were to rotate this 180 degrees, we would not have the same image. So let's look at this by table. We have f of x equals x plus 3. So if x is 0, then f of x is 3. If x is 1, f of x is 4. If x is 2, f of x is 5. If x is negative 1, then f of x is 2. And if x is negative 2, then f of x is 1. And again, by table, we can see that we don't have this sort of even or odd function, right? Because f of 1 is 4, and if this were an even function, f of negative 1 would also be 4. If it were an odd function, f of negative 1 would be negative 4. Instead, we don't see any type of symmetry here. 4 and 2 obviously are not the same number, nor are they opposites. So algebraically, let's look at that. We know that f of x equals x plus 3. So f of negative x is equal to negative x plus 3. And again, this is not the opposite of f of x, right? If we were to look at the opposite of f of x, which is x plus 3, that would be negative x plus 3, which would give us negative x minus 3. So this would be the opposite, but that's not what we get. We get this, f of negative x equals negative x plus 3. So therefore, this is neither even nor odd.